So that's one approach. That's kind of like what I learned in thermodynamics the first time. It's what Feynman observed in the Brazilian physics textbook. Plain statements that you're supposed to memorize. Now, as an alternative to that, why can't you do something like this? I'm going to go through really briefly, in a nutshell, what I did with the students. This is very condensed and it's a little different from the H-levels, but in a nutshell, this is it. Look at this. Oops. Look at this, magnifying lens. You ever notice with a magnifying lens, you can do, you can do something like this. For those of you who understand, I'll make the image of that array of light. I'll try it out. A picture shows up on the card. It's really good with a TV or a picture window or something. There's classrooms that had a picture window. They were all like, ooh, that's with a lens and a screen, you can make pictures appear. Do you ever see the front of a projector? Same thing. There's a lens in there, a curvy, clear thing, and a screen up there. I'm making a picture appear with a lens and a screen. Ever look inside a camera? Same thing. This is one of the fundamental basic ways you can make a picture, lens and a screen. Now, this picture-making organ that gives you a picture of the world in your head, I wonder if that works the same way. Let's cut one open and find out. It's soggy. So here is a cow's eye. Oh, ish, it's full of jelly. Oh, look, though, in the front there, I'm not going to turn this over, someone's full of jelly. There's a little blob in there that looks a lot like a lens. Look at the back of the eyeball. There's a pink skin covering the back of the eyeball. I have a lens and a screen. The screen, it looks a lot like skin. Well, let's see, with your normal skin, you feel heat and cold and pressure and roughness and wetness and stuff. Maybe the skin is kind of like the thing that makes you feel the picture. The lens makes the picture appear on the screen. Just like that one makes that picture appear on the screen. And maybe the skin then kind of feels it somehow. Well, then what? Oh, look, you can scrape it away. It's loose. It's not sewn down anywhere. Oh, except for that one spot where it's kind of stuck down. Look at the other side of that spot. The one, I'm not going to actually do it. If you scrape away the retina, you'll find it's loose except it's stuck in one particular space. And if you turn around and look at the back end, you see this little tendon-like thingy coming out the other end. You know where that goes? The brain. So the skin apparently kind of feels, the lens makes the picture appear on the screen, and the screen kind of feels it somehow, and then it tells the brain through this little cable. You notice the lens is kind of cloudy. The lens, if you do this actually, it's a bit cloudy. It's not a bit cloudy. How can a cow see through a cloudy eye? Well, this is the deceased cow, of course. Maybe it's kind of decayed or something. Maybe, lenses can decay or kind of milkify or cloudify. Could it happen in real people? Could it look through a disease or something? Could you get a cloudy eye? Yeah, that's what cataracts are. So that is sort of in a nutshell how I attempt to explain how the eye works. I'm trying to do more or less what Feynman's father did, to actually get them looking, questioning, looking for connections, comparisons, getting them thinking. The first approach is in this textbook. I think we call that the name of the bird approach, or the memorization approach. The whole style of science education is, here's the information, you memorize it. Sort of as if knowledge were water, and you could teach children as if you were pouring water into a glass. The way I'm trying to do it is the way Feynman's father did it. You get them to build their own knowledge. You get them in the habit of actually thinking, of looking at the world and doing something mentally with it. Okay. I wanted to go on to another point. This is more or less method. Two different methods or styles of teaching. I wanted to talk a little bit about the content and ultimately the whole purpose behind it. I think there's something a little more fundamental going on than just the style of how you teach. You give students information and stuff to memorize, or you try to lead them to a path of thinking. Because I think, and this is something I'm kind of working out for myself, and hopefully will still be somewhat clear, but I think at the root, the fundamental purpose that you have in mind for science education, why are we here? What is the point of teaching science? Two different answers to that question lead to these two different approaches. So, for the first answer to that question, what is science for? I want to come back to the book, and I want to give you an idea of the range of topics in this book. What is the content? Actually, not just the I, but the whole book. What is in you? What does this teach about life science? And I thought I would do this. I made a list of words that I could not find in the index of all the studies in the book. These are words that are not there. Intestine, esophagus, colon, stomach, digestive system, tongue, or tooth. The entire digestive system is gone from this book. It's not there at all. There's no discussion of how the body assimilates food. Nerve, brain, plexus, ganglia, neuron, spinal cord, or nervous system. The whole nervous system is missing. Now, I should point out nerve cell and brain cell are next. This book will teach you about the invisible microscopic grains that make up your brain and your nerves. We don't teach anything about the brain or the nerves, what the lobes are, what a brain looks like, what the connections are, or how you can find nerves in your own body. How? Femur, tibia, fibula, humerus, cranium, no bones, no muscles. Now, there is a section on the musculoskeletal system here. It doesn't teach you anything about particular bones or muscles in your body or where to find the biceps tendon. It's all very general. I found cartilage in one sentence only, and ligaments in 3 sentences. Evergreen, deciduous, conifer, monocot, dicot, wood, stem, leaf, sap, root. There's a little discussion of plant cells in the book. There's a little bit of discussion within the chapter on reproduction, on how in particular plants reproduce. But there's no discussion of plants. There's also no mention whatsoever of the whole fascinating world of fungus and mushrooms. That's all though. Insect, arachnid, crustacean, arthropod, mollusk, gastropod, whole classes and even whole phyla are missing from the book. Even within the vertebrates, marsupials and cetaceans and lizards, there's no mention of those. Birds and amphibians and reptiles and even vertebrates as a whole class, they are there, but only within the section on evolution to say when they evolved. There's no discussion of the family relationships or examples, or there's no discussion of animals. Carnivore, herbivore, omnivore, predator, prey, parasite, symbiosis, all gone. No discussion of interaction of organisms. So, what's in here?